How is the final keyword used in Java?
Okay, so basically in Java, I use a final keyword to indicate that a particular variable, method, or class cannot be changed once it has been assigned or overridden or extended respectively. Okay. For instance, a final variable must be initialized at the point of declaration or in the constructor and cannot be reassigned later. So I think that's use of final keyword in Java, and this
Mhm.
immutability helps in creating robust and, as we know, thread safe applications.
Okay. Can you give an example of a final class and its implications?
Okay, example. Okay, so let's consider a class, public final class. Okay. uh,
Mhm.
uh, okay, this class cannot be extended. It means no subclass can inherit from it. Okay. This is beneficial when we want to ensure that the behavior and characteristics of the class remain consistent and unchanged throughout the application. Okay, and obviously preventing other developers or
Mhm.
future code changes from altering its design. So I think this is the example of final class.
Okay. How does a final method differ from a static method?
Okay, so a final method in a class basically means that it can, as I already told you, that it cannot be overwritten by any subclass. Okay, that will ensure the method's behavior is preserved. Okay, and whereas on the other
Mhm.
hand, the static method belongs to the class level, not the instance of the class. Okay, so when the final methods push is it's kind of unchangeability in the context of inheritance, and same way, I mean, whereas the static methods are like persist to class-wide operations that are the same across all the instances of the class. So yeah, that's
Okay.
that's that's what the difference between them.
Okay. Can you just tell me that what effect does the final keyword have when used with variables?
What does if a final variable? So when we declare a variable as a final, so basically it means its values cannot be modified once it has been assigned. Okay. So this
Mhm.
turns the variable into a constant. Means that once it has a value, that value is permanent for the life of the variable. Okay. This is
Mhm.
particularly useful for defining constants in programs let's say if I'm using a variable called max and making it value the maximum like 9999999 and so on. So
Mhm.
I can assign that max variable as a final with a final keyword, and yeah, so that's where we use the final keyword.
Okay. How does the garbage collector work in Java?
Okay, so basically, garbage collector automatically frees memory by identifying and eliminating objects that are no longer in use. Okay, it basically works in the background and allowing us to focus on developing the application without worrying about explicit memory deallocation. Okay, and the garbage
Mhm.
collector's primary goal is to reclaim space from the discarded objects to prevent memory leaks, and it also ensure efficient memory usage. So that's a work of garbage collector.
Okay. Can you manually trigger garbage collection?
Mm, it usually happen at automatically, but we can call, I think, this garbage collection by uh, calling a system class method like system.gc. It's not guaranteed that a garbage collection will happen immediately or at all. So basically, the garbage collection process managed by, as we know, JVM, Java Virtual Machine, which decides the optimal time to run it based on the current state of memory and programs requirements. So I'm also not 100% sure, but I believe we can call that by that method.
Okay. So, how does the garbage collection contribute to memory leaks?
Okay, so garbage collection basically helps prevent memory leak by reclaiming memory occupied by the objects that are no longer in use. Okay,
Mhm.
if objects are still referenced within the application, they are not eligible for garbage collection. Okay, that's leading to the memory leaks. Okay, so basically, the effective memory management in Java involves not just relying on garbage collection, but also ensuring that unnecessary references to objects are also removed. So that's how garbage collection contribute to memory leaks.
Okay. So, can you explain the different types of reference in Java and how do they affect garbage collection?
Okay, different type of references. So I think there are major four types of references we have. First is strong, second is weak, third is soft, and then finally in the last we have phantom. Okay. Strong references prevent an object from being garbage collected. Okay, while weak references allow it to be collected when no strong reference exists. Okay, and I think soft references are similar to weak references, but are less aggressively collected and allowing for memory sensitive caches. Okay, and then the last we have phantom. So basically it is used for pre cleanup actions before an object's memory is reclaimed. Okay, so these references
Okay.
types helps in controlling the life cycle and garbage collection of objects based on the applications. So yeah,
Okay. So, can you explain class holder and its types?
class loader, right?
Okay. Yeah, yeah. Class
Okay.
loaders.
Okay. So, a class loader in Java, basically, it is a part of runtime environment that dynamically loads classes into memory when needed. Okay. So, usually we have three main types of this class loader. Okay. The one is, I think it's bootstrap class loader, which loads the core Java APIs, and then second we have extension class loader, which basically loads classes from the extensions directory, and then in the end we have system, or you can say application class loader, so which loads classes from the application's class path. And I think these type of class path helps us in managing how and when classes are loaded and influencing the behavior and performance of Java application.
Okay. So, can you explain the delegation model for class loaders?
Delegation model. Hmm. Delegation model. No, actually, I'm not sure on this.
Okay. So, how does class? Okay.
Mm-hmm.
Can you discuss the collection frameworks in Java?
Okay, collection framework. So basically, the collection framework in Java is a set of classes and interfaces that implement commonly reusable collection data structure such as layers, sets, and maps. Okay, and this framework is fundamental because it provides both an architecture and a mechanism to store and manipulate groups of objects efficiently. Okay, I can tell you example list allow for ordered collections and which duplicates, and on the other hand sets make sure element should be unique, and maps associate keys to values. So yeah, these are the parts of collection frameworks.
Okay. So, how do you choose between the different types of lists, sets, and
Mhm.
maps?
Okay, so basically It depends on the specific need. Like use list for ordered collection with duplicates when there are when there is no requirement for a duplicate for removing the duplicate elements. I can use list, and their elements are exist. Sorry, duplicates allowed, right, and their elements are accessed via indices. And on the other hand, talking about sets, I can use I mean I choose sets when I need unique elements, okay, with the faster access time, like maintaining sorting order, searching, and all those stuffs. For stuffs I choose sets. And now talking about map, so when I need a data structure that should contain key and value pair, I definitely use hash map and for rapid lookup. Okay, so yeah, that's how I choose.
Okay. So, can you describe how hash code and equals affect collections like hash sets and hash map?
Okay, so in collection like hash set and hash map, basically hash code and equals methods play important role in managing objects. Okay, so the hash code method helps in determining the bucket location for storing objects, while equal method is used for checking objects equality within the bucket. Uh, these implementation of these methods ensures that duplicate entries are avoided and the object retrieval is accurate and efficient. So for these type of things, we use these methods, hash code and equal method. So these methods basically are the inbuilt methods, but we can override. We can also override these methods.
Okay. So, can you explain the difference between synchronized collection and
Mhm.
concurrent collection?
Okay, difference between synchronized collection and concurrent collection,
Yeah.
right? Okay.
Yeah.
Okay, so synchronized collection, basically we can obtain those via methods like we have a collection sort synchronized list. Okay, they provide thread safe access by wrapping the collection with an object and that force mutual exclusion to its element. Okay, and on the other hand, concurrent collection is like those in the java.util.concurrent, concurrent package. It offers better scalability by allowing multiple threads to access the collection concurrently with minimal performance hit. Okay, by using some advanced synchronization technique like segment locking in concurrent hash map. So
Okay.
these are differences.
Okay. So, can you explain the concept of Java memory model and how does it ensure thread safety?
Okay, so Java memory model basically defines like how threads interacts with memory. Okay, they ensures visibility, ordering of operations, and atomicity. Okay, it provides the rules and guarantees for memory usage in multi-threaded environment, and they also ensure that when one thread modifies the memory, other threads can see those changes reliability and consistently. And now talking about how they ensure thread safety. So basically, this Java memory model ensure thread safety through happens before relationships, which provide the rule for memory visibility and ordering. I can give you example. So basically, locks and volatile variables are used to establish happen before relationships.
Mhm.
They ensure that changes made by one thread are visible to other threads in a predictable manner. So that's how this model ensure thread safety.
Okay. So, as you're talking about the happen before relationships, can you
Mm.
explain more about it?
Yeah, I can explain. So basically, the happen before relationship in Java memory model defines a partial ordering on all the actions within the program, such that if one action happens before another, then the first is a visible and order before the second. For example, a write to volatile field happen before every subsequent read of that field, and it ensures visibility of the changes across thread.
Okay.
Yeah.
So, what are the volatile variables and how do they work within the Java memory model?
Okay, so basically, volatile variables in Java are used to indicate data variables values will be modified by different thread. Okay, within the Java memory model, reading from and writing to volatile variables establishes a happens before relationship, and they ensures that changes to the variable are immediately visible to all the threads, and that reads and writes to the variables are not reordered with other memory operation. So yeah.
Okay. So now moving to the next question. Can
Mhm.
you explain synchronization in Java and its impact in concurrent processing?
Okay, so synchronization in Java is a mechanism to control access to a resource by multiple threads. Okay, it ensures that
Mhm.
only one thread can access the resource at a time. It's a crucial for concurrent processing to avoid issues like thread interference and memory consistency errors. Okay, however, excessive synchronization can also lead to some issues where threads spend more time waiting for access to a resource than executing, impacting performance negatively. I mean, the last one which I said.
Okay. So,
Hmm.
can you explain how can we handle deadlocks in Java?
Okay, so in order to handle deadlocks in Java, basically deadlocks occurs when two or more threads wait forever for each other to release resources. Okay, so we can use strategies like I can use strategies like avoiding nested locks. I can use lock ordering, or I can employ timeout based approaches like try lock or some others to prevent threads from waiting indefinitely.
Okay. So, can you explain log starvation?
Okay, so basically log starvation happens when one or more threads are uh, uh, unable to access a shared resource because other threads are constantly acquiring the log. This usually occurs in situations where threads priorities are uneven, causing the low priority threads to wait using fair locking mechanism where locks are granted, something like that. Yeah, I'm not 100% sure on this. Yeah, but yeah, something like
Okay.
that.
Okay. Okay. So, what are some alternatives to the synchronized keyword in Java?
Alternatives. Okay. Sorry, no, I'm not sure on this.
So, so the next question is,
Mhm.
what are the changes to the Java platform introduced in the most recent version that you are aware of?
Okay, so recent Java versions have introduced changes like the module system in Java 9 for better encapsulation and dependency management, local variable type inference, like now we can use VAR keyword in Java 10 for reducing boilerplate code, new factory method for collections in Java 9, then enhanced switch expressions in Java 12 and beyond for more concise and readable code. So yeah,
Okay.
these are the major changes.
Okay. Okay. So, how have these changes affect the way you write the Java code?
Okay, so these changes have made Java code more concise, readable, and maintainable. Okay, for example, recently I was talking about war keyword, right? So this basically keyword reduces the boilerplate code of declaring variables. I mean, now we don't need to write something big. So whereas the switch statements enhance, and now we have more fall through methods, and we can prevent our error. I mean, we can write more error prone code. So this and the another one is model system also has improved the scalability, security, and performance.
Okay. So, have you encountered any challenges while migrating code to a newer version of Java?
Migrating to a new version, actually, it is a we saw some challenges once we migrated. We saw some challenges like compatibility issues, especially if the code base uses some deprecated APIs or relies on features that have been removed or changed. So ensuring all dependencies and libraries are compatible with the new version and adapting to a new language feature. So I think these kind of stuffs are, challenged us.
Okay. So, how do you implement a file upload feature in a Spring Boot web application?
Okay, so implementing a file upload feature in a Spring Boot application, basically it involves creating a REST controller that handles HTTP post request and containing the file data. And I also use post mapping annotation to map the request, and request parameter can mention the file name inside the request parameter. Okay, so to receive the file, so this service layer then process the file, which may involve saving it to a directory or processing its content.
Okay. So, can you walk through the step to set up a REST controller to handle file uploads?
Okay, so to set up a REST controller for handling file uploads, first I would define a controller class with REST controller annotation. Okay, then I would create a method annotated with post mapping that maps to the URL endpoint for uploading files. Okay, this method takes a multi-part file or single file parameter to accept the file. Okay, inside this method, I would write the logic to handle the file, such as saving it to the server or processing its content. So yeah,
Okay.
that's all.
So, yeah, okay. So, suppose that if a file upload fails, that how would you handle exceptions?
So if a file upload fails, I would handle exceptions by using Spring's exception handling mechanism, such as exceptional handler annotation separately on the service file, or I can use controller advice for the globally exception handling. So these can catch exceptions like maximum upload size exceed exception for files that exceeds a size limit, and I can then provide a meaningful responses to the client, such as error message indicating the detail of the issues. So
Okay.
yeah.
So, can you explain how you would externalize configuration in a Spring Boot application for different environments?
Okay, so externalized configuration. So externalized configuration in a Spring Boot application for different environments involves basically properties like application dev properties, application test properties, application prod properties. I use profile annotation to designate which configuration is active in a given environment, and Spring Boot automatically loads the corresponding properties files based on the active profile. So yeah, that's how I use
Okay.
externalized. Yeah.
Okay. So, how do you manage application properties for multiple environments, such as dev, test, and prod?
So to manage application properties for multiple environments, I define separate properties files for each environment and use Spring Boot's profile feature to specify which configuration to load at runtime. Okay. This approach allows me to isolate environment specific settings such as database URLs and maintain clean separation of configuration.
Okay. So, what method can you use to inject configuration properties into your Spring Boot applications?
In Spring Boot, I inject basically configuration properties using the value annotation to load individual values. Or sometimes I prefer binding entire configuration classes using configuration properties annotation. Okay, so this allows for like type safe configuration injects and making the application more maintainable and reducing the risk of errors.
Okay. So, can you explain the management of application secrets in Spring Boot?
Sorry, come again. I didn't get you.
Uh, the management of application secret in Spring Boot. I just came to discuss or explain the
Okay,
management of
okay.
application.
Management of
Uh,
application secrets in Spring Boot. Okay. So managing application secrets in Spring Boot involves basically securely storing and accessing variables, external configuration files, secret management service like AWS. We have a lot of stuffs online like AWS Secret Manager, HashiCorp, Vault. So we can use these. We can consume these third-party services in our Spring Boot application to integrate, and we can use application secrets.
Okay. So, what strategies do you use to manage database passwords or third-party APIs?
Mhm. To manage database password or third-party API keys, I can use, we have a lot of strategies like storing them in the environmental variable or using secret management tools to dynamically inject them into the application at runtime. So I think this ensures that secrets are not exposed in code or version control system.
Okay. So, how can you securely access these secrets at runtime?
So securely access secrets at runtime, I use Spring Boot's integration with secrets management tools, which securely fetches and injects the secrets into the application context. And this can be done throughout the configuration properties or environment variables set up by the data. So yeah, that's how you can use
Okay. So, how does Spring Boot support data accessibility?
data access auditing. Yeah, sorry, I'm not sure on this. Data access auditing.
Okay.
Yeah.
Okay. Okay. So, can you explain how can you customize the JSON serialization and deserialization in Spring Boot?
Okay, so to customize JSON serialization and deserialization in Spring Boot, I use annotations. I can use annotations like JSON include to exclude null fields. I can use JSON property to rename properties. I can use JSON format to specify the data formats. And for more complex scenarios, I can create custom serializer and deserializer by extending JSON serializer and JSON deserializer classes, and then register them with the object mapper to control how objects are converted to and from JSON.